I can see by the dawn words have lost their meaning, but we're carrying on, and I believe.
Hi, I'm John. I'm a chemistry graduate student at UCLA, and now in this video we're going to be going over some chemistry topics. Hope you find this useful, and good luck in your course.
Okay, so now one of the first steps in determining molecular structure is establishing the molecular formula. Here, very similar to the IR spectroscopy video, I'm not going to be solving any problems explicitly, but I'm basically giving a series of steps that you can follow to help solve these problems. So, step one, what you want to do to systematically approach these problems, the first thing is determine the molecular formula and degree of unsaturation, also called index of hydrogen deficiency. So you're going to examine the molecular formula that you may be given and calculate the degree of unsaturation and try to deduce what information you can about the presence or absence of rings or pi bonds if you have a phenyl group, for example. The molecular formula that you have itself may be given in a problem, or you might have to deduce it first from mass spec data. Step two, look at the number of signals in your NMR spectrum. So you'll count the number of signals to determine the number of sets of equivalent hydrogens that are present in the compound. Step three, integration. And so you'll use the integration generally that's given and the molecular formula to determine the numbers of hydrogens that are present in each set of equivalent hydrogens. Step four, look at the pattern of chemical shifts. So compare the signal chemical shifts with reference tables or correlation tables that you have to determine which functional groups may be present. Now keep in mind that these are broad ranges and the signals of each type may be shifted either farther upfield or downfield depending on the specific molecular structure. Step five, look at signal splitting patterns. So you'll examine the splitting patterns for information about the number of nearest non-equivalent hydrogen neighbors. And then finally, step six, construct possible molecules from the functional groups that are present, the relative signal integrations, and any other information that you're given, especially the molecular formula and other spectra. And so you can confirm the correct structure by making sure that all of the available information matches. So what you're basically going to get at this point are a couple of different pieces of your molecule, and you basically just have to try to put them together like a puzzle.